Welcome to this YSL tutorial. In this video, we're going to teach you how to create your own user-defined scalar functions in Microsoft SQL Server. What we'll cover in this session are all the techniques required for you to create your own custom functions in your database. We'll just start with a description of what scalar functions actually are, then tell you how you can define a function, including specifying what inputs it will have and what kind of data it will return. We'll then add some code to a function to calculate an answer, and then show you how to use functions in a query to replace your complex expressions. We'll then move on and show you how you can alter a function if you need to add more code to it or tweak the way that it works. Before the final part of the video, we'll talk about some more complex functions using some programming techniques, and that's going to include using variables, using conditional statements like if, and how to return different answers based on conditions. So let's get started. Every SQL Server database comes complete with its own set of built-in functions. You can find them in the Object Explorer by expanding the database, followed by the Programmability folder, then the Functions folder, and finally the System Functions folder. In there you'll find a list of folders containing various categories of functions. For example, there's a date and time functions category. If you expand a category folder, you'll see the individual functions contained within. So to pick an example, here's the date name function. If you let the mouse cursor linger, it tells you what the function itself does. It tells you it returns a character string representing a portion of a date. If I expand the function itself, I can see it has a folder called parameters. And if I expand this, it will tell me what bits of information the function requires in order to make it work. So I've got two input parameters, a date part, so that's the unit or increment of time that I'm interested in, and then an expression, which must be date time, and that's the date that I'd like to extract a portion of. It also tells me that the function returns a particular kind of data as varchar data, which means it returns a piece of text. Now you can see that I'm using the date name function here in this basic query to calculate my own custom date format. So I've used it 3 times already to get the weekday name, then the number of the day of the month, then the month name, and finally I'm just going to tag on the final part, which is to return the year from the release date of films in my database. When I execute this query, I'll find that I get a calculated field containing the various component parts of my date. I realise I've made a little mistake there. I need 2 Y's rather than just 1. If I execute the query again, that's a little bit better. That's what I was after. So using functions lets you build new calculated values, which is very, very useful. But if I find that I have to write this expression out every time I want to format a date in every query that I write, I'm going to get very bored very quickly. Ideally, what I'd like to do is encapsulate the logic of this expression in my own custom function, and that's exactly what this video is going to teach you how to do. There's a couple of ways of adding a new function to your database. You can either use a template, or you can just write it out from scratch. If you want to use a template, you first of all need to identify which folder you're adding your function to. So use the Object Explorer, start with the root of your database, which in my case is movies, then the Programmability folder, then the Functions folder, and then finally a Scalar Valued Functions folder. Scalar valued simply means that your function will return a single value, so it's either a piece of text or a number or a date, and that's the type of function we're going to focus on building in this video. To add a new one, like in many things in SQL Server, you right-click on the folder name and then choose to create a new version of it. When you do that, you'll get this lovely looking piece of system-generated code, which is a basic template for creating new functions. There's a little bit of comment text which attempts to help you, but personally I find this terribly awkward to use. I don't think I've ever used the template to create a function in my entire life. I always write mine out from scratch. So what we're going to do is we're going to close down this silly system generated code page, and instead we're going to create a brand new query window. You can either click the new query button here or press Ctrl and N on the keyboard. And now we're ready to start writing our function from scratch. The first thing you need to write in order to create a function is almost literally that, the words create function. Following those two words, you need to think of a sensible name for your function. I always start my functions with the letters fn. That's a neat way to distinguish my functions from the built-in system functions, followed by some kind of descriptive name. I'm going to call mine long date. That's pretty much what it's going to do. Once you've decided on the name for your function, you then have to work out what input parameters it might have. And you can list the input parameters in a set of parentheses. How you lay this out is entirely up to you, but I favour the system whereby I open a set of parentheses on one line, close them a couple of lines further down, and then head back up and fill in the list of parameters. The parameter that I'm going to use must begin with an @ symbol. All parameters begin with an @ symbol. And I'm going to call mine full date. I'm also going to specify what data type that date will be. I'm going to say this as date time. If you have more input parameters, you can simply write a comma-separated list. So you'd add a comma, followed by the next parameter, and so on. But we only need one single input here. Once you've listed all the input parameters, the next thing to do is say what kind of data the function returns. And I know that my function is going to return a string of text, so it's going to be some kind of varchar data. So I'm going to say returns varchar max. I'm not quite sure how long the string of text will be, so I'm using varchar max so I don't have to worry about working that out. Almost there with the structure of the function. A couple more things to do. We're going to use the word as to then define what operations the function will perform. And although we don't need to do so in this case, I always find it's worthwhile adding a begin and end block so that you've got a neat place to encapsulate the logic of your code. And that's the basic way to structure the definition of a custom function. Now that we've defined our function, we can add all of the code that will make the function actually work, and that is calculate the date format from the date that we give it. Now the most important instruction that a function must contain is the one that returns the final answer, and that line always begins with the word return. Now normally this would be the final line in your function, but because we've got such a simple one, it's just going to perform one calculation, then we can actually write this as the first instruction. So we want to return the formatted version of whatever full date we pass into the function. And because I've still got my other test query open, I'm going to cheat a little bit here, and I'm going to copy what I've already written in my previous query. So, my function is going to return a formatted version of whatever date I pass in. One thing that I need to do is I need to replace any reference to an existing field name, film release date, with the name of my input parameter. Probably the quickest way to do that is with a find replace. So if I highlight all of this text, press Ctrl and H on the keyboard to bring up the find replace window, I can find film release date and replace with at full date. If I replace all, that should replace 4 occurrences. I can then click OK and then close down the find replace window. So there we go, there's my function completely defined. All I need to do now is execute the code to actually create it. Before you do that, you should make sure that you've got the appropriate database selected. So I've got the movies database selected here. You could also actually write a use statement at the very top of the script. So I could say use movies, and I must make sure to write the command go to make sure that create function is the first statement in the next batch. So finally, the only thing that remains is to execute the script to create the function. And of course what we're looking for is a lovely message, commands completed successfully. Once you've created your function, you'll probably want to check that it is where it should be. So to do that we can use the Object Explorer window. if I move my panel across, what I need to do is look for, again, the movies database, programmability, functions, and scalar valued functions. Now at the moment, I'm not seeing that there are any functions contained within there. That's simply because the folder has not yet refreshed. So I can either select the folder and click the refresh button at the top of the window, or right-click on the folder and choose to refresh it directly. And you can see now that I've got a little expander symbol, and there we go, I have my function fn long date. It fits in very closely with the definition of all the built-in functions as well. If I expand my function, it shows me a parameters folder, and if I expand that, it tells me that my function requires a single argument or a single parameter called @full_date. The one slight difference is that user-defined functions don't tell you what type of value is returned. So in a built-in system function, it tells you the return type. It doesn't for a custom function. So now that we can see that our function exists, all we need to do is check that it works. And to do that, we need a new query. To test my function, I'm actually going to cheat, and I'm going to reuse the query that I was writing earlier on. What I'm going to do is I'm going to strip out the big long expression that I had earlier, and I'm going to replace that with the function which should do the same job. Now I could just type directly into my code the name of my function, but you'll also find that you can click and drag from the Object Explorer. You can drag the name into your code. It's very important that you use the name of the schema as well. You must use DBO. In my case, that's the name of the schema used to create the function. So you must precede your custom function names with the schema that was used to create them. I also need to open a set of parentheses after the function, and then I need to pass in the name of the field, which contains the date I want to format, and that's the film release date. You'll often find that when you first create a function, the first time you try to use it, SQL Server underlines the function name in red, indicating that the name can't be found. That's usually down to the fact that the IntelliSense has not yet refreshed. So you can refresh the IntelliSense in a couple of ways. You can either head to the Edit menu, choose IntelliSense, and choose a Refresh Local Cache, or you can just press Ctrl, Shift, and R on the keyboard, and hopefully after a brief pause, the underlining will disappear. So now in the acid test, I'm going to execute my query and make sure that what I get in the results of this query were exactly as I had them before. So there we go, a successful test of our user-defined function. So once you've created a function, what if you decide that you need to change the way that it works? So for example, in our date format function, we could add on the suffix to the day of the month. So it says Friday 16th of July and Friday 23rd of January, etc. If you want to modify a function, you can do it in two ways. If you still have the page open which was used to create your function, you can actually head back to that script, change the word create to the word alter, and then subsequently make any changes that you want to. That's actually pretty straightforward. But you don't even need that original page in order to make changes. I'm going to close this one down without saving the changes. But don't worry, all I need to do in order to modify my function is to find it in the scalar valued functions folder, right click on it, and choose the option called modify. I could also actually choose script function as alter to new query editor window. These two options are equivalent. If I choose modify, I will end up with a new code page. There'll be some rubbish nonsense system generator code that you really don't need to use to modify the function we've created here. So you could actually delete those lines if you didn't want to see them. I'm going to do that. And what you'll have is essentially the function that you created, just with the word alter in front of it instead. All we need to do now is add in the extra code that will add on the suffix for the day of the month. So I'm going to click just at the end of the line which returns, this is the line which returns the day of the month as a number. So I'm going to actually remove the extra space at the end there. And what I'm going to do is use a case statement to work out which suffix to use. So I'm going to add case and end, and then after I've finished my case statement, I want another space, and then I would like to concatenate that to the remainder of my date, and then inside there I'm going to use another function, in fact, when the day of at full date. So this will check what the day of the month of my input parameter is, and I'm going to check if that is in the numbers 1, 21 or 31, and when that's true I would like to return the letters ST. I've got three other possibilities here as well. I'm actually going to copy the when statement here and paste it in once, twice. I can make a couple of tweaks here. Now if the day is either 2 or 22, then it will be ND, and likewise if it was 3 or 23, it'll be RD, and for everything else it'll be TH. So that's the tweak to the code that I wanted to make. What I have to do now is execute this page to make sure that the function is actually altered. It's very easy to forget to do that. I've done it myself on several occasions, so make sure that you execute the code to actually modify the function. At this point you could simply go back to a previous query and then try to execute it again to see if the changes have been made. So I'm going to execute this query, and I should see beautifully that I get the correct suffix after each day of the month. The great thing is as well that I can use that function in any query belonging to this database, so I can pass in any date and get the appropriate format. If I head to another quick query here that I've just built, I've got the actor's name and actor's date of birth, and if I wanted to I could use my DBO FN long date and I can pass in the actor's date of birth. And when I do that, execute the query, I'll format the actor's date of births instead. So that function is reusable in any query within this database. Okay, so we've written a basic function which essentially just formats an input and gives it back to the user. What about something a bit more complicated? What we've got here is a basic select statement with a single expression which works out the first name given a director's full name, first name and surname, and the way that it works is by looking for a space within the director's name and then returning all of the characters to the left of that space. So when I execute this query, what we should see is that for Steven Spielberg we simply get Stephen, Joel Cohen we get Joel. Not too difficult to understand. There is one issue with that though. If I try to attempt the same thing with the actor table, so I've got the same expression just based on the actor's name. When I execute this query, I'll see an error message. I get an invalid length parameter passed to the left function. Now the reason for this, if I comment out the expression and execute it again, the reason for it is because there's one really annoying pretentious person in my database with just a single name, Sting, and because Sting does not have a space within his name, then the function returns an error. So the char index function returns a 0. I subtract 1 from that, which gives me -1, and then I try to return -1 characters from the left of the name. It's a bit of an issue. It would be possible actually to solve that problem within the same select statement. I could use a case statement to check if char index returns 0 and then do different things based on whether that's true. But it makes my function and my query ever more complicated. Again, this is a great example of where encapsulating the logic in a user-defined function is a much more sensible way to approach the problem. And that's what we'll do next. So to get started with this slightly more complex function, again we need another new query window, and I'm going to say use movies. I'll try to say use movies. There we go. Go, and then the create function line. This time I'm going to call my function fn first name because that's what it's going to calculate. And again, just as with our date function, it requires a single parameter. This time it's going to be called at full name, and the data type will be varchar max. So those are the input parameters. The next thing I need to do is say what my function will return, and it returns varchar max as well. Finally, I can say as, then begin and end, and now I can start writing out the logic of my function. Oops, before I do that, I better change the typo I made in varchar. Let's make that spelt correctly. Now I can start writing out the logic of my function. So, I could simply, as I did earlier on, return the answer in the first line of code of my function. The expression would be quite complicated, but it would be possible to do. But as we're writing out our code in a user-defined function, let's take advantage of the fact that we can break down the logic into separate steps. What I'd like to do first is work out where the space is in somebody's name. And I'd like to store that value in a variable. So I'm going to declare a variable called @spacePosition. And I'm going to declare a data type for that as int, or integer, so it's a whole number. Now I'm going to set the result of @spacePosition, try again, equal to the result of my char index function. Char index is a built-in system function, and there are two required arguments. The first one is the string of text you're looking for, so that's a space, and then subsequently the string of text you're looking within, so that's going to be @full name. Now I know that char index returns the number, the character index position of the looked for text. If it fails to find the text you're looking for, it returns 0. So if I know that, it means that I can use an if statement to check which condition is true. What I'm going to do is I'm going to check if the char index is 0, I want to store the entire name again, the person's full name. Otherwise, I want to get all the characters from the left of the full name. So I'm going to use another variable to hold the answer. So I'm going to declare @answer as varchar max. I spelled it correctly this time. And then, after I've worked out what the space position is, I'm going to use an if statement. If @spacePosition equals 0, what I would like to do is set @answer equal to @full name. So if I don't find a space, then a person's first name is their full name. Else, what I would like to do is set @answer equal to the left function. Now, the left function again has two arguments. I want to get characters from the left of full name, and the number of characters that I want to get is equal to @spacePosition minus 1. So at that point, I should have my answer stored in the answer variable, whether there was a space in the name or not. All I need to do now is tell the function to return @answer. And that's the logic of my function complete. All that remains is to execute the code to create my function, and there we go, command completed successfully. So that's our more complex function created. What we need to do now is test it. So before we do that, it's worthwhile mentioning that this is still a fairly mild example of what you can do with all the code available to you. So we've used a couple of variables and an if statement, and we've recorded videos on how to use variables and more complex if statements and loops in SQL Server. They might be worth a watch to give you a bit more of an idea about what sorts of things you can do. But do bear in mind that the more code you embed within a function, the more time your function will require in order to calculate. So functions are not the most efficient part of SQL Server, user-defined functions at least. So do bear in mind that they're not necessarily the quickest way to achieve a result, but they are still quite useful. So last thing we're going to do then, now that the function has been created, I want to test to see if it will work. So let's remove my non-working function from earlier, my non-working expression, and instead I'm going to replace it with a call to my function called firstName. Now again, you'll find that by default the name does not appear, the name of your function doesn't appear in the IntelliSense list immediately. So what I can do is edit IntelliSense, refresh local cache, and this time when I've done that, I should find that my firstName function is available. The name that I'm going to pass in is the actor name, and I should find that when I execute this query, I now return a sensible result with no errors, and lovely old Sting is still just called Sting. So there you go, there's a summary of how to use user-defined functions in SQL Server. Hopefully you'll find that useful. If you've enjoyed this training video, you can find many more online training resources at www.wiseowl.co.uk.